Hello students, in the previous video we have discussed about the nth term of a GP, and in this video we are going to discuss about the sum of n terms of a GP. We have seen that a geometric progression can be represented by the sequence a comma a into r comma a into r square a into r cube comma so on up to, if we take only up to n terms, that will become a into r power n minus 1, because the nth term will be equal to a into r power n minus 1, which we have seen in the previous lecture. So now suppose the sum is equal to s. So s will be equal to a plus a into r plus a into r square plus so on up to, let's take the last two terms are a r power n minus 2 plus a r power n minus 1. Now we need to find the value of s in terms of a and r. So to do that, let's multiply this equation with r. So when we multiply this equation with r, it will become s into r is equal to, when you multiply r with a, it will become a into r, plus when you multiply r with the second time, it will become a r square plus a into r cube plus so on up to a into r power n minus 1 plus a into r power n. Now subtract the first equation with the second one. So minus. So when you do this, it will become r into s minus s is equal to. So here we have minus a from the first equation, and minus ar plus ar cancels out, and ar square and ar square also cancels out. Similarly, we'll have all the terms up to a into r power n minus 1 will cancel out. So we'll be left with minus a plus a into r power n. Now taking s common, we'll have s into r minus 1 is equal to, taking a common, a into r power n minus 1. Now when we divide with r minus 1 on both sides, we'll have s is equal to a into r power n minus 1 by r minus 1. So this will be the formula to find the sum of n terms of a GP, that is equal to a into r power n minus 1 by r minus 1. Now if suppose we have the common ratio, the absolute value of the common ratio is less than 1, and the number of terms is infinity, so n will be equal to infinite. Then in this case, the sum will be equal to a into r power n minus 1 by r minus 1. But since n is equal to infinity, we need to take limit n tending to infinity a into r power n minus 1 by r minus 1. Now we have mod of r less than 1. We know that limit extending to infinity a power x will be 0 if the absolute value of a is less than 1. So if we use this property here, then we can say that limit tending to infinity r power n will be 0. So this will become a into 0 minus 1 by r minus 1. That will be equal to a into minus 1 by r minus 1. When you multiply this minus 1 to the denominator, we'll have a by 1 minus r. So this will be the sum when we have n tending to infinite and the absolute value of common ratio is less than 1. Now let's take a few examples and try to find the sum of the terms in geometric progression. So if I take the first term equal to 2 and the common ratio equal to 2 and number of terms is equal to 6. So using the formula, we have sum is equal to a into r power n minus 1 by r minus 1. So a is equal to 2 into 2 power 6 minus 1 by 2 minus 1. This will become 2 into 2 power 6 is 64 minus 1 by 2 minus 1 is 1. So it will be equal to 2 into 63. That will be equal to 126. Now instead of directly giving the value of a, r and number of terms, suppose I give a geometric progression, that is 3, 6, 12, 24, 48, 96. Now if you want to find the sum of these terms, here let's try to find what is the relation between the terms. So here we can see that 6 by 3 is equal to 2, and 12 by 6 is also equal to 2, and 24 by 12 is also equal to 2. So we can say that the given sequence is a geometric progression, and now to find the sum of these terms, we can use the formula to find the sum of n terms of a geometric progression. So we'll have sum is equal to a into r power n minus 1 by r minus 1. Now in the given geometric progression, the first term is equal to 3 and the last term is equal to 96. The common ratio is equal to 2. because the ratio between the consecutive terms is equal to 2. Now using the formula of nth term, we can say that an is equal to a into r power n minus 1. That will be equal to 96. So we have 3 into 2 power n minus 1 is equal to 96. 2 power n minus 1 will be equal to, so when we divide 96 by 3, it will be equal to 32. And 32 can be written as 2 power 5. When we equate the power on 2, then we'll have n minus 2 equal to 5. So the number of terms will be equal to 6. From this, we'll get the sum will be equal to the first term multiplied by r power n. That will be 2 power 6 minus 1 by 2 minus 1. So the sum will be equal to 3 times 2 power 6 is 64 minus 1 by 1. And that will be 3 times 63, which will be equal to 189. Now if suppose we have a geometric progression with infinite term, that is 1 comma 1 by 2 comma 1 by 4 comma 1 by 8 comma 1 by 16 comma so on up to infinite terms. Now here we can see that the common ratio is equal to 1 by 2 by 1, that is equal to 1 by 2 comma 1 by 4 by 1 by 2, which will also be equal to 1 by 2 comma 1 by 8 by 1 by 4, that will also be equal to 1 by 2. So the common ratio will be equal to 1 by 2, and that is less than 1. So we have the condition that mod of r less than 1 and the number of terms is equal to infinite. So we can use the formula directly that sum is equal to a by 1 minus r to find the sum of the terms of this particular GP. So this will be equal to, the first term given is 1 by 1 minus r is equal to 1 by 2. So we'll have 1 by 1 minus 1 by 2, which will be equal to 1 by 1 minus 1 by 2 is 1 by 2. Since we have 1 by 2 in the denominator, then we can bring the 2 to the numerator and becomes 2. So we can say that the sum of terms in this infinite GP will be equal to 2. Hope you understood well. Thank you.